Hello everyone. My camera's not working. Hold up a second. It might not be plugged in. Should have checked that. I am so enjoying this awesome conversation you're having about maths because I think today one of my slides says maths is equal to life. So for those of you having a bit of a joke about it, I'm back. It was indeed the camera not plugged in. Okay, someone's unplugged the camera and we just plugged it back in. Hi everyone, hope you're having a good day. Beautiful weather outside. So hope that you're enjoying. Some of you are outside enjoying this lecture. Some of you are inside also enjoying the lecture. Why not? You know what? I'm going to flip over to this side. So today we're going to have another amazing lecture. But first I would like to show my respects and acknowledge the Bedegal people and of elders past and present who are the traditional custodians of the land on which this lecture takes place. And then we can continue with our lecture. So today we're going to be, I think it doesn't like me moving, so it keeps blurring me. I might stop moving. Here we go, standing still. Okay, so today we're going to throw ourselves into the thick of it. We're going to be doing a lot more C and a lot more with the code. So hope all of you have enjoyed your labs over the last week and hope that you have been able to pick up a lot more about Unix and also, you know, getting more comfortable with the terminal commands and also a bit more comfortable with gedit, because hopefully we'll be able, you know, to continue. And as we go on, you will get a lot more comfortable with all of it. So, who said lab was a pain? Our labs are so much fun, I think. Okay, so let's get started. And I'm on a PDF today because that means I can draw better on it. Or not at all. Nope. All right, so what did we do on Tuesday this week? We talked about, someone said the kangaroo humbled you. Yeah, indeed. I didn't quite go into the / details so much, and maybe I should have. So I'm glad that you got to have the lab so you could see how the backslashes work as well. So that was quite nice. Okay, so on Tuesday, we did some welcome, we did introductions. We also talked about the course administration and how COMP1511 works. So if any questions, just pop them in the chat. Today in the chat, we have the lovely Tom Killingback. We have the lovely Tammy, and Shrey has also joined the chat. So we've got a few of us in the chat today answering your questions. So hopefully we will get through all the questions. If you have asked a question and it is not getting answered, please ask the question again, because it might have, just gotten lost in, as it moves up, and we might have missed it. But so please ask it again if no one's answered your question, because then we will answer it. And then some questions they will be passed to me as well to talk about if it's a really big question as well. So we will cover all of your questions. Okay, we also talked about how to get help and the best ways to approach learning programming. And so I wanted to reiterate that programming can get hard, and maybe you will think that in a few weeks' time. We kind of build and build and build until it gets, quite a bit harder. But the best way to get through it is to practice lots and to build up your, dictionary of all the different types of problems that you can have, and to practice that problem solving as well. So actually, how do I solve this problem? Which we will try and do in the lectures as well. So we talked about what is programming and kind of looked at Linux and working in Linux. We looked at a terminal, which I think everyone was super excited about, no doubt. I always get excited. Why not? You look like a genius when you're using the terminal to non-computing people. Okay, so also what is happening is that we will be scheduling some help sessions, and so next week we will release the details of those help sessions and what time that they are running and how to log into them. You'll be logging into them through Blackboard Collaborate, so we will provide more details as well on the help sessions. Probably at the end of the lecture I'll just give you a little bit more information, but the timetable will come out sometime next week. So today what we're going to do is we're going to talk about variables and how we store information. And variables are pretty important. Without variables, we can't really do much, and we can't really do much coding. So pretty important. I guess you've had your share of variables in maths as well. So, you know, with the pronumerals, so I guess there's more coming, and then we're going to do some maths. But it's going to be very basic maths. Don't worry, it's not going to be as hard as you're doing in 1131 and in discrete maths. It's just going to be basic, you know, maths operations. We're going to talk about conditionals, so running our code based on some sort of condition being met and how we do all of that stuff. And then we're going to look at if statements. So pretty exciting. The first taste of actually, you know, making decisions and, you know, and branching out on our code. So really making our code a little bit smarter and being able to decide what it wants to do as well. So that's going to be pretty exciting stuff. Okay, where is the code? Tom, could you please post the link in the link in the chat? I was going to say the chat in the link, but that's not the right procedure. So please feel free. Once we start coding, I will tell you which file I'm in, and I will also share it. Right now, it is not. It's not shared, so you won't actually be able to access the file. I've just realized I haven't schmodded it, but I will as soon as I get to it. And then you'll be able to see the file. Okay. All right, let's do a brief recap because why not? Let's remember what we did, because we wrote our first program and it was superbly exciting when our computer spat out at us, hey. So that is a great thing to spit out. And it was our first taste of doing some coding. So pretty exciting stuff. So if you remember, we had a few parts to our first piece of code. We had the first part, which was our... Is the pen not working now? My pen is not working. Nothing is working. Technology! Okay, I'm just going to use the mouse for now. Okay, so the first part of our... Okay, but the mouse is working. I wonder if the pen needs charging. Okay, so the first part of it was our header, and we learned that in C and in every other language that you will ever learn, it's important to have good style. So we want to be able to also present our program, because programs and code is something that is read by a human. So we want a human to be able to read our code and understand what's going on. So the first part of our program, always at the top, is our header, and the header says, what does our program do? So that's someone that goes into our file and is able to read straight up what they're actually doing. So that's the header, usually has a description of what the program is doing. It has the name and the date as well. Yeah, so whoever said they don't have access to variable.c, you do not. It's because I haven't given access yet, but I will give access as soon as I use the file. So you'll be able to see it in a moment. Okay, then we have our lovely hash include statement, which you're going to have basically every time that you do something, you're going to have this hash include statement. And the hash include, usually you will learn how to hash include other things besides stdio. Stdio is your standard input output, so it's important for getting input from the terminal and also for putting output out to the terminal. So we are including this library, and by including it, we're telling our compiler that we would like to include some code that we didn't write, but is available to us from some standard libraries. And we would like to borrow that code because, well, why rewrite something that's already written so well? So that is what allows us to be able to access this printf in here. And then what follows afterwards is something called a function. Now we're going to learn more about functions a little bit later on. So you don't yet need to worry about what parts of it means. I want you for the next week to remember this formula, is that you open your function with this at the top and you close it with this return 0 for now. And we will discuss more in detail what it means and how to get rid of all of it and what makes sense of it and how to change it to other things as well as we go on. And our function used this function in here, also called printf, which was inside this stdio file. And printf puts out to terminal some text, and we put out to the terminal a little hey, and then we had this lovely symbol here, which if you remember means new line. So, and the new line there means, you know, please press enter basically. So there we go. Okay, so now let's move on. Okay, so I'm struggling with all technology today. No, here we go. Okay, computer memory. So how does a computer remember things? How do we make things happen? How is it that we can actually make code? How is it that we can actually do anything on the computer? And someone said, I don't understand what's the int main void for really. You don't need to understand it yet. Don't worry. We will talk more about it in the coming weeks. So for now, I want you to think about it like a formula as well. And same with that return 0 at the end. For now, I want you to think of it as a formula of having that first function. We will discuss more in detail what it actually means. Okay, don't worry. We will go back to it. So it's basically the int main void is where we start reading the code. That's the first thing that will be read. That's where you start, you know, that's where you go in and read line by line after that. And the return 0 is the last thing that you read. And when you do return 0, you're telling the computer, okay, everything went okay and the program is finished. And you hit the last curly bracket and it's out. So that's what it means in a very basic sense, but we're going to look into it in a lot more detail as the weeks go on and what it actually means and how can we change it. Okay, so how does a computer remember things? Obviously well, not obviously, I'll take that back. Maybe obviously to me because I've been doing this for a long time, but the computer remembers things in ones and zeros. So it's all in your ons and offs. Yep. So all your switches that happen to be the way the computer understands what's going on. So the computer memory is literally a big pile of these on and off switches. And these on and off switches are called a bit. And this bit is the smallest possible unit in computing. Okay, because it's a choice between 0 and 1, and that's it. So it's 1 bit. Now, 1 bit is not really enough to store a lot of information. So what happens is that we often collect these bits together into bunches of 8 bits, and that's called a byte. So super creative names. And actually, I'd like some trivia about the naming. Can you please, in the chat, post some trivia? Because there is some good trivia about the names. Okay, so we call these bytes. Now we don't do a lot of working with these bits and bytes, but it's important to understand very basically how it all happens because we're going to talk a little bit more about it, and then you go on to talk a little bit more and more about it as you keep going in computing. So what does this look like? And I like to talk about this also in a very broad sense. This is not examinable or anything like that, but I think, again, it provides you a better understanding of what it is you're doing and how how C can help you. So what does that actually look like? So there is a little bit happening because when we execute code, what happens is that the CPU will process the instruction and perform the basic arithmetic. The RAM will keep track of all the data needed in those instructions and operations. And the way it works is it has something called a heap and a stack, and you don't really need to know about it, but I will refer back to it as we go on. But you will have these wonderful things in memory called a heap and a wonderful thing in memory called a stack. And when you declare your variables and when you initialize your variables, so when you are in control of your variables, well, you're not in control really of the memory assigned to them, they go inside the stack. So when we now start to learn about variables, those are the variables that are going to sit inside your stack. And the bigger you build up the stack, you might cause an overflow, which is where the website Stack Overflow got its name. Because it's a very common problem when the stack and the heap, bump into each other, or the stack grows hugely. And it's very hard to do well, it's not very hard to do. In week 8, you'll see it's not that hard to do to create a problem. But right now, for you guys, it'll be a hard problem to do in the next 5 or 6 weeks. I'd love to see someone crashing it just to prove me wrong. Okay. Why is it now not moving? Okay, how about I do this, because then I can just go to the thumbnail. So now it decides to move. Okay. Okay, so what's a variable? What is a variable? Does anyone know what a variable is? I'll take it out to the audience. Oh, well, thank you. I've just, yeah. Yeah, a way to store some information, something that stores something, a container, a stored piece, all great definition. Something that can change in value. Yes, thank you. So someone's mentioned something that varies. That's a very good definition. So a variable is called that because it can vary. It can change its value throughout your whole program. So we're holding something and, 2 minutes later we decide actually we want it to be something else. We're not happy with what it is, so we can change it. And then 2 minutes later we decide we want it to be something else, so we can change it again. So a variable is just really something that can change its value throughout our program. And someone said as opposed to a constant, that is constant. Well done. We will be talking about constants a little bit later on. So yep. So very good. Okay, so a certain number of bits that we use to represent something, and that's important in C because in C we tell our compiler how many bits to store in memory for a particular variable. And an integer has a different number of bits to a double, so an integer number, a decimal number to a character to something else, and we'll look more into that in a second. We're not up to infinite loops yet. We'll do those next week. And a variable is made with a specific purpose in mind. So what kinds of variables are we going to look at today? Today we're going to look at 3 types. Did you see that? I'm showing you 8 fingers, but I'm saying we're going to have 3 types of variables. So that's going to get very confusing. 3 types of variables, and the camera's all off. There we go, 3 types of variables. So we're going to look at integers. So an int, the good old int, that's right. And an integer is a whole number. So things like 0, 1, 2, 3, 4, 5, blah, 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 and so on and so forward. So then we're going to also look at a char. And a char is a single character. And that single character could be a letter, so something like a little a or a big A, but characters are not just letters, and we're going to look at more into that in detail because I'm going to tell you why it's not just letters. And then we're also going to look at doubles, and doubles are basically floating point numbers. So they're your decimal numbers from what you remember from like maths as you learnt it in school. It was always called a decimal number. Did someone say my nails are covered in blood? They're not. They're bright pink. It's because I let a 5-year-old choose my nail color. So who knows what it will be in 2 weeks. Hold that thought. It's going to be another wild color. Okay, so a double is a floating point number, which means it's a decimal. So 3.14159, 8.534, 7.11, whatever. So anything that has a decimal point in it, that's called a double. And someone's asked, is symbols considered characters? Indeed they are. And there's a specific chart of characters that I'll show you how to access in a few slides as well. So each of these has a different number of bytes, and they're all allocated in memory once the program is run. So what happens is that we have, someone said you could say the color of the nails is a variable. Indeed it is. And it changes every 3 weeks without fail. So what have we got? So we've got an integer, and an integer has a certain number of bytes. Then we have a char, again a certain number of bytes, and a double as well, a different type of bytes as well. And so it's important to understand that each one of those will take once you start compiling, it will take a certain amount of memory and it will hold it for that variable. So we let C know how much memory we want to take. Okay, let's talk a little bit about style. What can you name your variables? What should we be naming them? What do you reckon? Do you reckon I can name it? Oh, well, I've now got the slide up there. But you really don't want to have, A, B, C, D, E, F, G for no particular reason. The name should be a description of what that variable is. Because remember that your code is really for humans to read and understand. And a human cannot quickly understand random variable names that make absolutely no sense. You want to have something that provides a very brief description of what that variable is actually doing. So things are, like answer or diameter. So things that are actually describing what that variable is storing inside it. So we always use lowercase letters to start our variable names, and we will learn about that why in a second. And it's part of this styling. C is also case sensitive, so that means that answer with a capital W in the middle is not the same as answer with just all lowercase letters. So they're two different variables. So that's important to remember. It is case sensitive, and there's also some words that are reserved. So you can't call your variables return. As you've seen, we use it inside our function, so it's a special word that C keeps to itself. You also can't call it things like int and double and char, and they obviously can't be used because they're also special words that C reserves for itself. So you can't use them, and you will be told that if you try and use them. It will not compile. So if you want to name your variable something that is multiple words, so not just one thing, you can split the words with underscores. And this is called snake case. So you can, have one thing and then an underscore and then the second word of whatever you want it to be. So be wary, don't have something that has, seven words strung together with the underscores. That's not good because that's not easy to read and understand. You really don't want to have more than, three words maximum there strung together. Okay, so basically we name our variables in ways that make it obvious what they're representing. And remember that someone else has to be able to skim your code and know what you're saying or doing. And the best thing is if they're able to just read your code, and through your use of well-named variables, they're able to understand what your code is actually trying to do and how you are achieving it. So you really want to be giving descriptive names that make sense and that all kind of come together to tell a story. So basically you have to be a master storyteller and put your variables together in a way where they are telling some amazing story. Okay, so integer is the data type is called an int. So you will see me you'll see me do a declaring and initializing of an int in a second. So it is a whole number, no fractions or decimals. It most commonly uses 32 bits to represent itself, and that means it's also 4 bytes. We'll talk a little bit more about that. And so keep in mind, I've said most commonly because it's not always the case. Computers and, we have to make things difficult for everyone. So that's caused issues as well. And we'll talk a few more about those issues. And that gives us exactly 2 to the power of 32 different possible values. So the maximum is very large, but it's not infinite. Okay, so we can run out of space. We can get to the point where something is, you've run out of range, you've gone beyond that, and that means you're going to have some serious problems. So the exact range is from negative 2 to the power of 31 to 2 to the power of 31 minus 1. Who knows or who can guess why the maximum is 2 to the power of 31 and minus 1? Who can guess that? Yeah, well done. Oh my gosh, everyone's so on point here. Yeah, because of the 0. That's right. So unfortunately, we have to consider the 0. Well, I don't know, maybe fortunately, we just have to consider it's just a fact of life. 0 is there and we have to take it into account. All right, so let's talk about characters. And I might show you this one because this one is neat, maybe. So a character in C can also be represented as an integer. Mind blown, I hope. I hope everyone's mind is just blown by this. Amazing. And that's because a single character variable holds an ASCII value. And you can actually, in Terminal, have a look at what characters are available to you by bringing up the ASCII table. And if you don't know what ASCII is, it's an old thing for old people. No, it's still used today. So type in ASCII -D, and what that does, the hyphen, so if I type in just ASCII, it brings up something that's a bit ugly. So I always, it brings up several values, so in hexadecimal and also in decimal values. So I always use ASCII 'D because it gives me a much neater table and it only presents each one of them as a decimal value. And you can see that the letters are represented by a number as well. So the capital letter A is actually the number 65, and the capital letter B is actually 66, and then the little a is 97, and so on and so forth. But what happens is that you have this bunch of other characters available to you in the ASCII table. So you've got characters like exclamation mark and these brackets here and so on and so forth. You'll notice some of these things here, which are a whole bunch of other things. You can explore some of them if you like, but some of them are not used anymore, like 7 bell. It makes a little ring sound, and it's quite old school. But there are lots of things that were used in the past, and so they're not quite there now. So someone's asked, what is an LF? It is a feed, a line feed. Because when you used to have a typewriter, when you went to the new line, you had a line feed. You had to move the typewriter across. And basically, that is an equivalent character for a new line. So that's nice that you've went straight for this number 10, which is something that we will actually even talk about later on, because it will impact how we read characters as well. So the line feed is important. It's going to be one that we talk about as well. So it's exactly like the \n. So it's a new line. And that means that when you read in a character, you might read in that line feed, and we will talk more about that problem next week as well. Okay, so let's have a look then back to the slides. Where is preview? I'm not using my own computer, and I'm so used to it being on the left, and it was on the far right. Of course it was. Okay, so the syntax to assign a single character is to put the character in single quotes. So if you want to assign a character to something, you are to say it's the ASCII value, to say it's going to be a character, a letter, you put it in tiny little single quotation marks. So for capital letter A, the character is the big A, and the int stored is the number 65. Okay, and then you use a char to declare a character. So we use this keyword here, char. That's going to help us to declare it. We'll do that in a second. And what it means is that we're able to also, because they are ints, we're able to do some maths with them as well, because they're really integers, so we can really add, subtract, and do lots of things to move around our chars. Okay, and finally, the third type of third type of variable we're going to do today is a double. And a double is a floating point number, which really just means that it is a number with a decimal point inside it. So the floating point, what that means is that the point can be anywhere in the number. So it can be, after the first number, or after the second, or after the third. So the points are in different places, but with the same. So the point is floating about. And it's called a double because it's usually 64 bits. And if you remember, an int was 32 bits and a double is 64 bits. So it's exactly double of what an int is. So hence the double size of our integers. So the int was 4 bytes and the double is 8 bytes. Okay, so let's try some code. Let's go do some code. Yay, and let me move into the directory. Okay, you should be able to see that file now. Oh, did someone say it's their birthday? Happy birthday to Krishna. How exciting to be in a lecture on your birthday. Well done. The commitment is commendable. Okay, let's open this file. So I'm going to use gedit again. So remember, I'm going to say gedit, the file name, and then I'm going to put the ampersand symbol so that I can still have control of the terminal when I use my ampersand. Okay, let's have a look what we have here. I might make this screen a little bit smaller so that you can see both of them. How is that looking? Is the font big enough? Can everyone see everything? Yep, excellent. I'm going to clear the screen so that you can see even more. Okay, and let's have a look here. Okay, so we're going to do our first lot of variables. So this program will show you how to declare and initialize a variable. So there are two parts to having a variable, okay? And we always have a variable. If I want to have a variable in my program, there's going to be two steps to it. First is I have to declare the variable. What this means is I'm letting C know that I need a variable. And here I have to let it know what type of variable I also want. Okay, and after I declare the variable, I also need to initialize it. So this means I'm going to give it some initial value. Now that value can change throughout the program. That's not a problem. So, but I have to give it some sort of initial value to start with. So you can, if you want, you can open this file and you can follow along. You'll be able to see my changes if I press save in the file, if you follow the link on the computer, or you can write the code yourself if you want. You don't have to write any code at all. You can just sit back and listen and I don't know, enjoy the sound of my voice. Not that that's really something that people normally do, because my voice is not that pleasant. We did have to actually, Tom Killingback and another person in this lab were having a conversation, and it turned out that they both did theatre because their voices were both very mellow and very, very, very nice pronunciation. I do not have that. Okay, that was just a sad story. That was a sad story. Okay, so let's try it out. Let's give it a whirl. Okay, so the first thing we want to do is we want to hash include our standard input output studio, because that will allow us to have access to our input and output sort of things, that we can take something from the terminal, we can put something back onto the terminal. And then let's do our formula. So int main void, bracket, bracket, bracket. And then here, if you remember, I'm just going to put the back end of my formula. So up here is where we will start reading. So when this is where our code kind of starts. So this is where we'll start reading. And over here, when we return something, that's where we finish and get out of it. So that's really all that it's saying. And we will place stuff in here in the middle. Okay, so let's have a look. Let's declare, what should we declare first? An int. Let's do an int first, because I don't feel Be a bit weird if we started declaring much harder things first. Let's do an int and a double first. Okay, so, and also you will see me doing a lot of commenting during lectures. You do not need to comment your code to the extent that I will be doing in lectures. The only reason that I am doing so much commenting is so that you can see what each line of the code does. So please do not do this much commenting. In fact, it's bad style to have this much commenting. So you will have a lot less comments, but I will have a lot more comments. Okay, let's have a look. So first, let's declare an int. I don't know, what should we have an int? What should it be called? What should our int be called? My goodness, this is always so much pressure to come up with a good name. I'm just so tempted to write integer, which is terrible. Don't ever do integer. Okay, okay, var1, it's still not very descriptive, but it could be okay. Oh, well, it is someone's birthday. Should we have, Tom's suggesting age. Whose age? Not mine. All right, we'll go with age, but Shrey's suggesting totally good variable name. The next one, I'll take one from the crowd. We've got integer. Someone also thought integer could be good. Yeah. Oh, someone did suggest age as well. Okay, love it. And we'll do another one next time. Okay, someone wants a bowling score. I see you've read up on assignment 0. Fantastic. Okay, let's have int age. Now I don't know whose age to use. Okay, let's say we're just declaring it. I'm going to do it in one line. So let's say it's int age. And the second step of it is to initialize it. So now to initialize it, so to declare it, what I'll have is I will state a data type here. Okay. So the data type is of type int, and then the name of the variable is age, and then I finish everything with a semicolon. So to declare an int, I will say what data type it is, and then I will say what name it is, and then I will finish it with a semicolon afterwards. Okay, and then to initialize it, I'm going to use the name of the variable, and I'm going to use $=. And of course, there's a lot of suggestions. Everyone is very happy with the meaning of life. So let's just go with the meaning of life, which is 42. And if you don't know why the meaning of life is 42, then you need to do some reading of one of the classics, which, by the way, I couldn't actually finish and get past page 15 because I just couldn't. But it's in there. Okay, so... someone's asked a great question. What will happen if I write int age is equal to 42.42? You will get a compiler error because you are saying, I want an int, but I'm actually giving you a double. So it's not going to work at all. Okay, so people are just going straight. Yes, you can both declare and assign it on the same line. I was about to do that next. So notice here that there's only one equal sign, okay? And you're going to get two, you can do a few things in C. So to assign something, okay, you have one equal sign. So one equal sign means assign this value. And what happens is it goes to this side, it reads this 42, and then it moves it into the left side. So it moves it into the assignment. And yes, someone has said you can declare and initialize on the same line. How amazing is that? You can really save yourself so much, lines. So you can say int age is equal to 42, and it is exactly the same as doing these two lines of code here, int age and age 42. So you can do it all at once. You can declare it, and then you can assign a value to it. Okay, fantastic. So that was, that's it. You've done it. You've got an int now. You've declared it and you've assigned it. And if you wanted to later on in the code, because it is a variable that varies, we can also say now when we refer to it onwards in our code, we don't need to say the int anymore. The int is there in the beginning to let C know how much memory do we need to hold for this variable. So now we can just say age is equal to, and let's say I'm now going to 19, And now that just means that you have reassigned the value of this variable. So it was 42 over here when it started, and then when it goes to the next line, it's going to assign the value 19 into it. So what's going to happen is it's going to have, let's say we're declaring an int age. This is how well I draw boxes with a mouse because the pen is not working. I'm sorry. So this is int, and the name of it is age. Oh, struggling. And when we assign the number 42 to it, that goes inside this box. So we've got a variable with 42. And then when we reassign to it the number 19, that's crossed out and it becomes 19 in here. Okay, someone said, what do two equal signs do? Hold your thought. We're coming to two equal signs. You're just too excited, jumping the gun. We're about to go. We will get to two equal signs, don't worry. And Jack's asking, can you initialize twice, which is another really excellent question. You cannot initialize twice of the same thing, but you can obviously initialize as many times as you want. Sorry, initialize. You can't declare the same thing twice if you have the same variable name, but you can. So you can't do, I'm just trying to understand what your question means. I think you mean to say, can I do this twice? Okay, let me know in the chat if that's what you mean. Okay, so that was an int. Now, if we do a double, okay, double follows exactly the same rules. So first we declare it. And now because we're declaring a double, it's going to be called a double. And I'm going to call it the most fascinating thing called a decimal. And again, I can then initialize it. And I can say the decimal is equal to 3.4. Fantastic. Or again, the same as an int, I can do it all in one line. I can say double decimal is equal to 3.4. And that will do all the same things. Okay, I think, yeah, like what's already, yeah, so you can't do this twice. You can't do this, but you can reassign it by doing this. So you can't declare the same thing twice. Okay, so that means we've got a decimal as well. So now you've got an int and a decimal. But what on earth do we use this for? Because it'd be pretty useless without, everything else under the sun. So in this, someone's asked, how about a float? So in this course, we don't really use floats. We use the double instead of a float. Okay, so let's do some exciting things. Let's output it out to terminal. Okay, I'm going to comment out some of this, and I'm going to keep this here, and I'm going to comment this out as well. Okay, so let's do to output out to terminal, and we've included our standard input output, which is amazing. So that means we've got access to a printf statement. So let's printf, and inside printf I'm going to say the age is. Okay, now what does this mean when I type a %d in there? Okay, what happens then? Now, if I want to output something out to terminal, I have to use something called a format specifier. Now, for an int, that is called an %d. So the % is what tells it it's going to be a format specifier, and then I mention what type it's going to be. So the same way as when I declare that it's an int, when I want to print something out to terminal, I have to let them know what type am I printing out to terminal, okay? And in this case, if I want to print out an int, then it's going to be a %d. So %d is used to output a integer. Okay. I think there's a note from Tom. I don't know what his note means. That didn't go as well as we hoped. I can also see I'm really red. There's no air conditioning in this space and it is so hot. Okay, %d is used to output an integer. Someone's asked, what is the one for doubles and chars? So %d is used for an integer. Why not? Let's do %lf is used for a double, and %c is used for a character. And we will practice all of them, okay? So amazing. I think someone asked, what do these funny little squiggly things mean with stars and dashes? What it means is that I am super, super lazy to comment things out by using a double slash like this. And you can comment out larger chunks of code by simply starting it with a backslash and a star. And when I want to finish commenting it out, I do a star and another slash. And that says, please comment out this chunk of code. So if you notice, when I opened the whole thing, it just turned everything blue as though it's a comment. And only when I closed it up, it kind of knew at which point to finish that. Okay. Yeah. So it's basically to comment out a larger chunk of code, which I kind of wanted to do here without doing the double backslash everywhere. Okay, so then let's continue this output. So now this format specifier has said that I'm going to placeholder for an integer there, and I'm going to also do a new line afterwards so that it goes down, one, so that it doesn't confuse us. And then what you have to do, I can't just close this bracket now because I have said to it, okay, can you please output an integer? I need to tell it, what integer do you want to output? Okay, the computer's not that smart. It has to be step-by-step instructions. So I've told it I want an integer, and here I will put a comma, and then I will add the variable name that matches that data type that I want to print out for it. So let's save it. Let's erase this. Let's go back to this. No, we won't go back to this. I need the arrow so that I can have control of the terminal. Okay, let's compile. So I'm going to use the DCC, and then my file name is called variable, not .x, .c, and I'm going to do a -o because I'm going to name my output variable in super creative manner. I'm going to run it. It has compiled okay, so everything is great there. And then I'm going to run it by doing /variable, enter, and it says the age is 19. So you can see that over here the age was 42, but because I reassigned it, the value of age is now 19. So that's what it will output here. If I had this printf statement and I had it on this line here, then it would output 42 first and then 19. So why don't we try that as well? So let's compile that again, and then let's run it. And so now what it will do is the first printf statement will capture this 42, and the second printf statement will capture the 19. And remember that when we read the code, you're reading it line by line. So we'll read 42 here, then it will print out the statement, then it will go to 19, then it will go down here to do the next printf. Okay. Yeah, so someone said you can't just write printf the age is age. No, you have to tell it what you want to insert in there. So you have to put a placeholder in, and it has to be off the right data type. So it can't just be it will not guess for you. It will not, it's not really a magical, it's not a magical thing. Is the memory address for 19 and 42 the same? Oh my gosh, that's a very good question. A little bit far in advance. I think we don't talk about that for a little bit. I'm going to save that. That's an excellent question. I want you to ask me again in week 5 when we talk about memory, because then I'm actually here to show you how it works with my boxes. Okay. So %d is only used to output an integer. %lf is used for a double, and %c is used for a character. So you have to tell it what's going on. You have to tell it what data type it is. So I can also really do, you know, more than one thing in here. So let's say I've got age 19, and then let's say I'm going to have a second age, and this second age is going to be, I don't know, 35. Okay, oh, why not? Let's go for the third age as well. So I'm going to have a third age, and the third age is going to be 12. Don't know why, just numbers. Oh, someone said they can't wait for pointers with a crying face. Please stop. We're still in week 1. Calm down. It's all happening. It's all happening too fast for me. Okay, so I've got the ages percent %D. What should we do? Second age? No, my goodness. Percent %D. Third %D. Okay, so I can do many placeholders in here. Okay, many placeholders in here, and the way to do it over here is they have to be in the same order. Okay, so this one here will agree with the first mention. The next one will agree with the next mention. So this variable will go inside this, and then my third one will be whatever I list third. So let's try that out. Let's compile it again, and let's run it. And now I've got first age is 19, the second age is 35, and the third age is 12. So you can have, you know, many variables as well going if you needed to do that, because often it's not just so simple as you just print out one thing, you know, everyone's happy. You often need to do more than one thing. So it's good to have that, the ability to do really as many things as you want. Okay, should we try a double? Why don't we try a double? Let's do a double. Okay, I'm now going to do a larger commenting out. So I'm going to move my star hash here, because what I want to do is I want to comment out everything with an int, but I don't want to delete it because I want this code to be available to you when, you know, if you go and have a look at it in a second, or maybe even, you know, whenever you go to look at it. Okay, so let's do our double that's called decimal. So let's say we have a double decimal, and let's say it's 3.42. Why not? And then I'm going to printf the decimal is, and we'll take a break in about 3-4 minutes. So the decimal is, and so now here, instead of that %D, I'm going to have a %LF, okay? And then I'm going to new line, and I'm going to tell it which variable I want to place in there as the placeholder. So my decimal is going to print out in here. So let's see what it prints out. Okay, let's run it. I've got some sort of error. Let's have a look what the errors are. Oh yes, read definition of decimal. So this is what happens when you try and declare something twice. It's not going to work. So I've got my declaration here of decimal, and here suddenly I have it again. So you know what? I'm going to comment this out, but it doesn't matter which one I comment out. We're going to start our code over here. Okay, let's do it again. Let's compile it again, and let's run it. Okay, so now look at this. It's printing out 3.420000. Okay, that's not looking that pretty. That's a lot of zeros. What happens if you want to shorten it up? What happens if I know that I want 2 decimal points when I'm going to output my answer? Does anyone know what we print out if we want to have it to 2 decimal points, for example? How do I shorten it up? Does anyone know? And it's, please say no if you don't. I'm just putting it out to the audience. LF stands for long float. I hope that helps you to remember it. And that's why you get all these zeros as well. So it's a long float. Oh, people are so close. Oh, someone got it as well. Almost got it. So you have to write 0.2, which just before your LF. And it's telling me that I want it to 2 decimal places over here. So everyone had some really good guesses as well. And a few people knew what's going on. So we've got our 0.2 LF and then a new line. So now if we do it again, let's compile it. And let's run it, and it's now going to have a beautiful 2 decimal places going for us. Okay, so that's your That's your double. So that's your double. So now we've got our C, and I'm going to leave C for after the break, I think. Yeah, I'm going to leave C for after the break. So what I'll do is I'm a little bit behind the time, but that's okay. We'll catch up. We'll catch up. Let's go to our break, and we'll have a 5-minute break. Hang on. I hate this mouse. Can it be noted? I hate this mouse. Okay, I've got a little thing for you here, and I'm going to... Okay, 5-minute break, and then we're going to come back and do a little bit more. Well, a lot more. Okay, 5-minute break. All right, here we go. We're back. We're back. The pen is fixed. You will all be pleased to know. The air conditioning is not fixed, so you'll just see me getting more and more red as this lecture goes on, but it could be fun to just watch that until I just burst. Like Willy Wonka in the Chocolate Factory. Although I wish I was, I don't know, eating chocolate as opposed to... Actually, I don't really like chocolate. Anyway, that was just a tangent now. Okay, let's do our character, because we've now done an integer, we've now done a double, but what about a lovely character? So what I'll do is I'll take that comment out and I'll move it even lower again. And then let's do a character. And I'll do this so that you can see what I'm writing. Okay, so let's say we want to declare a character. So the same thing, and I guess everyone's now comfortable at declaring and initializing on the same line. So I'm going to declare and initialize a char variable on the same line. So what I'll do is I'll use the keyword char to say that I want a type char. So that means that my variable is going to be a char. It's going to be a character. And to be super creative, I'm going to call it character. And then I'm going to give it a value. And I'm going to put it in tiny little apostrophes. So the one apostrophe to let C know that it's a character, that I want it to be a character. And so those little one apostrophes, they say, okay, that's going to be an ASCII character. Okay, so semicolon, let's not forget that. Okay, and then if I print out, again, I'm going to say the character is, and then I'm going to use the %C format specifier, and I'm going to have a new line, double apostrophe to close, comma, and then I'm going to say what is the placeholder for. So character is the variable that I want in there. Someone's asked, can we use double quotes instead? You cannot, not yet, because double quotes mean something different, and we will learn about what double quotes mean in week 4 or 5. So that's going to be something to look forward to. You've got 2 equal signs, you've got quotation marks, double apostrophes, it's going to keep on giving, I promise. You're just going to be amazed at what it can keep on giving. Okay, and so now if we compile it and run it, the character is S. Amazing. And someone's saying, what if you want your variable to be multiple characters? Well, that's something else altogether, isn't it? So when we have a variable that is multiple characters, it is really something that's called a string, and we're going to learn about that in a few weeks' time. Okay, so yes, double quotes is a string, but we're not going to learn about it yet, so don't worry about the string yet. Okay, so I think someone wants to know, what is the point of a char? Why do you need a char? Oh, and someone's just popped out there, when does char become useful? I love it so much. Char is quite useful in a few situations, and actually I go over it in week 4, but now you get the bonus content of why it's useful. There's a few reasons that chars are useful to us, and the reason for that is sometimes we need to be able to do something one character at a time. We need to be able to process things one character at a time, as opposed to doing it in a big, string of text. And there is other reasons as well. Also, a char is it's only 1 byte. Okay. So basically, it also has, you hold up less memory when you use a char as well. It can only hold 1 character, okay? And sometimes that's very useful to us as well, because of this ability to be able to do something 1 character at a time, to take in 1 character, check it for something, and output something depending on what's going on. Okay, but we will talk more about it in the coming weeks, I promise. And it's hard to also, because I want to compare it with doing it when you're not just using a single chart, because then it becomes a lot more obvious why you would want something that can only hold one character, and why would that ever be useful as well. Okay, let's have a look here. So we've done printing out to the terminal, but what about now taking something out from terminal? And someone's going ahead. Scanf only exclusive to char data types. No, scanf can be used with all the data types. And there is this thing, so you've got printf, and we've used that includes stdio.h, okay, and inside stdio.h, so the printf is the output. So to output to terminal, we use this printf. And to input to terminal, from terminal, so to take something from the terminal and read it in, okay, we're going to use a scanf function. So scanf is basically the cousin of printf, the sibling. Printf puts something out to terminal, and scanf takes something from terminal and puts it inside the variable that we have. So why don't we have a look at how it all works together? Okay, let's have a look. I'm sorry, it's so hot in here. Okay, okay. So let's do, I might move my little star and slash down here, and let's do a whole new section that is coming. Okay. So when we scan something from the terminal, we need to have something to scan it into, okay? So you can't just scan something and have nowhere to put it. So you need to have a box to put something that you take into. You need to have somewhere to store it. So let's do an integer first, okay? Let's do an integer first. Let's do int, and what should we call it? Let's call it integer, okay? So we've declared an integer, and as you've noticed, I haven't initialized this integer. I've only declared it, okay? And the reason for that is because I'm going to initialize it when I put something into it with scanf, but you can initialize it there as well, and then scanf into it, and it's going to change the value. So I'm going to give a prompt. Please enter a number, and I'm going to spell it correctly. Okay, so this is just a prompt. I'm not putting anything out. I'm not doing anything. And now I want to let the user put in what number they want. Okay, so note that the scanf looks very similar to the printf. Okay, so you've got your scanf, you open your bracket in exactly the same way, and you have your double quotation marks, exactly how you have in a printf. But inside the double quotation marks, you have a format specifier that will tell scanf what is it looking for, what data type is it looking for. Okay, so in our case, I want to have an integer. I've asked them to enter a number. So the format specifies %d. So when I say scanf %d, what I'm saying is I'm telling scanf to look for a number, okay? And then I have to tell it where to put it into. So it's very tempting to just enter integer here and be done with it, but that's not how scanf works. Okay, for now, for the next few weeks, I want you to trust me. Pretend it's just magic and put an ampersand symbol in front of this, okay? The ampersand symbol basically tells scanf the address of the variable in the memory, but you don't really need to know anything about that yet. You just have to trust me that that's the way you have to do it this way, because you're scanfing into a particular section in memory, and this is what tells the address in that memory. Okay, so you have to do it. So someone's asked, it's a pointer. Not quite. It's really just giving the direct address of the box that's sitting somewhere in memory that I want to pop my number into. and assign it that value. So let's try running it and see what it does. So I'll compile it again, and then I'll run it again, and then it says please enter a number. I'm going to enter a 13, and then I should have printed something out to show you that it's taken it in and that it was successful, but I did not. So let's do a printf statement out here so we can see that it's actually working. So I'll say the number you entered is, and then I'll do a %d and I'll do a new line here, and then I'm going to say integer is the variable that I want. Okay, and that will show me that it's actually scanned in my number correctly. So I've compiled it. Now I'm going to run it. Please enter a number. I've put in 13, and the number you entered is 13. So what it means is that it's taken this number 13, it's popped it, it's gone to the address of this variable, and it's popped the 13 in there. And then what it's done is it's printed it out when I've asked for this variable to be brought back to life. Okay, so that's great. That's an integer. Okay, you can do the same thing for a double as well. So we can do it for a double. Let's do it for a double quickly. And then you can do it for a character. And there's something very special about a character. Actually, you know what? Maybe someone keeps saying, why didn't I put a \n for please enter a number? So I can put a \n. It just means go to a new line to enter my number. But I don't think it looks very nice because I want them to enter it on the same line. But it's not really. It's just, you can, the \n is just telling it to go to a new line. Okay, it's not really doing anything special. Okay, I'm going to maybe leave you to try a double. So it's going to be all the same, except you're going to declare a double, and here you're going to have a %lf instead of a %d. I'm going to do a char as well. So let's do a char, and we'll call it a character. Okay, and I'm going to printf enter a character, please. And then I'm going to scanf a character. Okay, so now I'm going to use a %c here, and I'm going to tell it where to go. And remember, for now, you have to put the ampersand symbol, and then you have and character, because that's the name of the variable. So I'm telling it to go to that address and pop it in there. And then I can output it out. And over the next week, you will see, over the next few days, because I'm going to do it on Tuesday, you might, when you're practicing this outside of the lecture, you might find a problem with this %c when you enter certain things in. And we're going to talk about that next week because I want you to find perhaps what this issue is. Okay, so I'm going to say %c is what I want to do, and I'm going to put a new line after it. And I forgot to enter what I wanted to come out as. Okay, let's try it out. So now we're doing a %c. So I'll compile it again and I'll run it again. Okay, let's enter a character. I'm going to do a little s. Fantastic. If I run it again, I can do a big A. If I run it again, and remember that characters can also be things like exclamation marks as well. So remember that you've got your ASCII table, so it can be anything on that ASCII table. Oh, and that's not nice, is it? Because it's the wrong size. So anything on here is a character, and anything on here can be scanned into this lovely, lovely char data type. Okay, someone's asking, what about prompting a user for name? We're not going to do that for a little bit. That's going to be a few weeks from now. Okay, so we're just doing very simple, one thing at a time still. But in a few weeks, we will absolutely do, taking in a line from terminal as well. Okay. So, again, over here, when we do a %d, the computer is looking for that type of data type, and it will scan in a number. It ignores all the white space around it, okay? But when you have a %c, I want you to find the mistake, what happens if you have some awkward things, because %C is so special. It's not just letters, it's a whole bunch of things before as well. Okay, so that is scanning in as well. We've done well. Now, someone before, when we were talking about variables, mentioned something about a constant. Okay, who knows what a constant is? Who can, I don't know, guess what a constant is? Yeah, well done. A number that stays the same, you can't change it, something that you cannot change. Yeah, so a number that doesn't change. Well done. Excellent. So sometimes we have variables in our program, but sometimes we're going to have things that are constants as well. Okay, so what it means is that it will never change its value throughout the program. And instead of using that constant all the time, declaring, initializing it and then using it throughout the whole thing, you can define it as a constant. It doesn't have to be, someone said, okay, let's just do a few of these and then we can go on. And yes, it doesn't have to be a number when you hash define it. And I've just jumped ahead by saying hash define. Okay, so the way you define a constant is you will do them before your main, okay? So let's do a comment here and let's say define some constants. What's a good constant to define? Okay, so someone said, but weren't we giving them constants so far? Like we specified age, which was an int, was 34. That's not a constant because I can change my mind 2 minutes later and assign a different value to it. But if I have to, if I'm saying, okay, the age is 34, that will never, ever change in the program, then I want to take that up the top to hash define it into a constant. People have some great constants there. I can see that everyone is coming off the HSC with the lovely formula sheets there. Speed of light, gravity, Planck, yep. Okay, so to define a constant, you use the keyword hash diffube. I've invented something new. You use the keyword hash define, okay? And then what you do is, let's do pi, okay? If you notice, I'm doing this in capital letters. So as part of our style, anytime we have a constant, we do it in capital letters. And the reason for that is if we then use that constant in our code, we can straight away say, oh yeah, that's a constant. I can see that it's going to be a constant. And then I give it a value. So 3.1415, whatever else, okay? And in there we also use the meaning of life. I can do that as well. So the meaning of life, and that's 42. Hash define, I don't know, you can say first letter, and that letter is A. So you can, anything that doesn't change throughout your code is going to be, anything that doesn't change your code is going to be a constant and should be hash defined, because it makes for good style when you use these types of definitions for them. Because instead of writing, 42 each time I need to, instead of writing 3.1415 each time I need to use the value of pi, if I actually refer to it as pi, it makes my code much easier to see. And much easier to read for a human. And remember, the purpose of the code is for a human to be able to read them. So these are not variables, but these are constants. So these are things that I'm defining that are never going to change throughout the code, okay? Someone said, okay, because this is a character and characters always go in single apostrophes, whereas these are integers, this is a double, so they're not in the ASCII. So anything in single quotes, I'm saying it's an ASCII value, okay? The single apostrophes is ASCII values basically. Do the constant always have to be in capitals? So not particularly, but the style guide and good style, okay, means that we want them to be in capital letters, because then when you refer to them in your code, we know straight up that they were constants, okay? So it makes it much easier to read the course, the code, and to understand what's going on in the code as well. Okay, so how's that? Is everyone still with me? Anyone still with me? Yep. Okay, everyone seems to be with me. Excellent. Is there a constant keyword for constant? The hash define says that we're defining a constant. All right, fantastic. Let's do it. Let's continue on. I'm going a bit over time. I'm sorry. Yeah, okay. So good. Yep, so I forgot to mention there is no type for a hash define. If you've noticed, I'm not mentioning that it is a double. I'm not mentioning that it's a number. I'm simply saying I'm defining a constant and I'm giving it this value. Okay, so the hash defines, the constants, they don't have a type attached to them. Okay. Oh, and someone's just asked the why not constant double pi. So the constants don't have a type attached to them. Just hash define, whatever the name is, whatever the value that you want to give it. Okay, let's do, yeah, I think it's time for some maths. Let's do some maths. Yay, maths. Everyone's excited to do some maths. Anyone excited to do some maths? Let's do some maths. Let's do some maths. Okay, let's do some maths. Let's have a look, because there are some weird things in C that happen to be with maths. Okay, let's declare some things and then let's do it. Okay, so let's do number 1 is equal to 5. Let's do number 2 is equal to 10. Okay, what should we do? Okay, so I might actually declare something to store a result in as well. So I've declared and initialized a variable called number 1 and I've assigned 5 to it. I've declared and initialized number 2 and I've assigned number 10 to it. And I've said that both of them are of type int. Okay, and this is important in C as well because it affects the maths as well. So we will talk about that in a second. It's one of the quirks of C. So Kenny's asking hash include math.h. No, because we're not going to be doing anything that requires math.h. So if anyone is wondering, math.h is another library that has a few mathematical functions in there and more complex maths things that we could do. But we're not going to be doing everything simple like plus, minus, divide, multiply is available to you right here. So we won't need to include it yet. We will not use it in this lesson. You might need to use it later on, and we will talk more about all the standard libraries that are available to you. So don't worry. Okay, let's have a look. So we've got our result. So let's do something with it. So now I want to say result, and I'm going to assign to it some value. And let's do some pluses. Let's do number 1. Let's spell it correctly, otherwise it won't compile. Plus number 2. And you'll notice I'm using a bracket because brackets, the same as in normal maths, give precedence in C as well. So you can say the order of how you want things calculated by using the brackets. And then I'm going to print out the result of it. So print out result D. I'm going to do a new line to make it look better. I forgot to say what I want to put in there, and I want to input out the result. Okay, who's going to calculate the result for me quickly? I chose very easy numbers to start with. 5 and 10, 5 plus 10, 15 times 10. Oh my gosh, I chose really easy numbers. Applause to me. Okay, here we go. I forgot the semicolon. Okay, and back to here. Semicolon, save that, and let's try compiling it again. Okay, and let's try running it. And it should give me the result is 150, which it does. Yay. Okay, so that is just some very simple maths, and we can do quite a bit in in maths and what we can do, but there are some quirks as well in C, okay? And I've provided you a few like trivia things as well, because I think it's really interesting to see, you know, those integer overflow errors. So we talked about an integer has, it's not infinite, it has an end, you know, to it. You can't go over it in the computer because it's using 32 bits to be stored. And so there have been a few issues. So if you add two very large ints together, you might go over the maximum value, and that might roll back around to a minimum value. And that's how Ariane 5 exploded. And you can see more details on that. I've provided a few links. So it was quite a catastrophic problem from that. Also, the Boeing 787 had to be rebooted every 248 days, which is 231, 2 to the power of 31 hundredths of a second. And so I've provided a link to that as well. It was a bit of an engineering problem as well. And then in sort of less destructive examples, I don't know if anyone, I don't know, am I too old, or do you know what Gangnam Style is, that song? Does everyone know what Gangnam Style is? Yeah, I'm not too old. Yes, success. So basically that one, it maxed out the YouTube counter, and that provided a bit of a problem. So I've provided a link to that as well, because it's pretty fun to see that happening. So the YouTube counter, it maxed it out. It went beyond the limit of what an int can go to. So yeah, so they had to change the type that they used to accommodate that, which was pretty funny. And because ints might not always be 32 as well, they might not always be 32 bits, which is even more fun. It depends on the operating system and the computer that you're using. So, you know, just you know, Epic, you have to make a lot of guesses sometimes, and you have to accommodate a lot of things as well. So there's a few quirks, okay? So in C, there is a problem when you're doing some division, okay? Well, it's not a problem when you're doing division. It's not really an issue. But let's say we have, yeah, I'll show you here. Okay, let's say we have number 2 divided by number 1. Okay, that seems to, oh gosh, we don't want to do that. Okay, so that's going to work out nicely, isn't it? I think so. It's going to give me 2. That's very, very nice, because 10 divided by 5 is equal to 2. There's no remainders. It's very neat. It's very clean. It's just, that's great. What happens if that is actually 11? What do you think it's going to give me as my answer? If it's 11 divided by 5, what do you think is going to be the answer? How does everyone know it's going to be 2? What happened to that remainder? You are right. It's going to give me 2. Well done. So that's the thing in C. If you use 2 integers and you divide those 2 integers, your answer is going to be an integer. Okay? So if both of the numbers are integers, the result will be an integer, which means that you're going to have some problems, because your remainder is just going to be goodbye remainder. We don't care about you. So, and if either one of the numbers are doubles, the result will be a double as well. So what happens here if I make this a double? Okay, well it won't, that means I have to make my result a double as well to store the, okay, so let's have a look here. Oh gosh, and this is not going to let me do anything because this is going to be wrong. So let's have a look what it does for me here. Okay, and so now it's going to divide it out, and it's going to let me keep the remainder as well, because I've turned it into doubles. So one of them's a double, the result has to be a double as well. So you have to be, and what happens also, what happens if I keep these 2 as an int? Okay, so I've got an int and an int, but I'm pushing my result to be a double. What do you reckon it will do then? What's everyone's bets? Let's place the bets. What do you reckon it's going to be? Will it be, what will be the result? What do you reckon? Okay, good. We've got a few guesses. I'm going to compile it first. And then I'm getting ready to run it. Oh, my goodness. Well done. Very good. Well done, everyone. So you're right. Because both of them are ints, the result is going to be 2. But because I've said, okay, well, it's going to be a double, it's just added some decimal points for me. So you have to be careful when you do division in C, because division is a bit funny. So how can we get the remainder only in that case? How do we get just the remainder? So what happens if I just want the remainder? And what happens if I can't spell? Yeah, modulus. Well done. Okay, so you would have, the modulus is the percent symbol in C. And so if I say number 2 modulus number 1, what that result will give me is it will give me just the remainder. So in this case, so as you can see, my error message here is that the format specifies double, but my argument has type int. And the reason for that is because here I've said the remainder is an int, but here I'm trying to make it look for a data type of double. So these are some things to look out for when you're writing your own code. Okay, let's compile it and let's run it. And we get the result is 1 because 11 divided by 5 has a remainder of 1. Exactly. Well done. Okay, so those are a few interesting things that we can do. Okay, let's go back and do some... Okay. So you're going to be going over a lot of these things in the tutorial and lab as well. I know sometimes the lecture goes a little bit fast. Let me know in the chat if you need me to slow down. There are some points that I can slow down. There are sometimes I'm not able to slow down as much, but I would like to slow down so that everyone knows what's going on. Okay, I would like to, if possible, talk a little bit about if statements. So if you have any questions, okay, a few people are saying slow down. I will slow down. If you have any questions, pop them in the chat as well. And we're going to talk a little bit about if statements as well. Someone said, can you go through assignment 0? So you will do a little bit of assignment 0. You will be going through it in the tutorial, okay? So don't worry. The first part of it, I want you to really just to read assignment 0. And you just really have to printf something out. Someone wants me to print the constant. Sure. I can even do some maths with a constant. Should we do that? Okay. Let's say I'm going to use my meaning of life constant. I can say it here. I can say meaning of life modulus number 1. So what's that going to be? My constant was 42 and it's going to be modulus number 1 is 5. So what's going to be the remainder here? That should really give me 2. So let's have a look if it's going to do that for us. Let's compile it. And what's going on here? It's just given me a warning. It says that I haven't really used this variable. I'm not being nice to it. I've left it alone. So it's okay. It will still run. I'm just going to ignore it for now. And the result is 2. Well done. Okay. If you want to print a constant, it's very good questions. Do we not define the data type for constants? No, we do not define any data types for constants. So I want you to play around with it as well. Try printing it. See what you can do. The best way to learn programming also is to make lots of these mistakes, because then it tells you, yep, actually, I can't really do that. So I need to find something else to do. So try a lot of different things out. Sometimes I will not be able to try every different possibility in the lecture, but I want to leave you with some things that you can then break the code with. Then you can pull this code out from the lecture and you can actually play around with it yourself as well. And remember, if your question hasn't been answered in the chat, please ask the question again, okay? because sometimes it scrolls through fast, especially when you ask a question and then I ask a question and everyone answers my question, the question is lost. Okay, so please ask your question again, okay, even if it's, you know, from 2 minutes ago. Okay, let's talk a little bit about if statements before we finish, and then we can do a really simple if statement, and I'll use constants again in that if statement. Okay. All right. So sometimes in our code, okay, we want to make some decisions. Okay, and we'll do another. People are really worried about constants. I'll try and print out a constant towards the end, okay? Because you can use it however you want. You just can't ever change it, okay? But you can use it as you would a variable, but without changing it. You can never change it. It's constant. It's always the same. And you can print out a constant. Yes, you can. And we can play around with that as well if we have time today. Okay, so let's do some if statements. So sometimes we want to make decisions based on what the information is that we have at the time. And it allows us to have our program, so branch between sets of instructions. And we can do that by using if statements. So if something is happening, then I want to do this, else I want to do something else. So usually a great place to use an if statement is when you have to make a decision. So if you have a problem, a decision problem, and the question is yes or no answer, that's usually a perfect place to use an if statement as well to help make that decision. So for example, is the number even? Is a number larger than 10? Is a number prime? And so on and so forward. So anytime you want to ask a question and the answer to that question is yes or no, in just English, so asking something in your head or out loud, doesn't matter. So if the answer would be yes or no, then you could probably use an if statement in your code. So should we try an if statement in our code? How does everyone feel about inserting an if statement? No, not used in C, Critica. No, we use if, else, if, else, if, else. Yep, I can slow down. I will slow down. Let's do one if statement. Let's do a simple if statement. Okay. All right, let's do, I'm going to comment out this part because, and I'm going to use these two numbers to do my if statements. Okay, so the way that an if is structured is it is a keyword in C, so you can't name your variables if. Okay, but I'll have an if, then I will put in some sort of condition in here. So this is not a condition, I'm just writing it out. So if there is some sort of condition, then I'm going to open a block of code. Okay, so remember that inside the curly brackets is a certain block of code. So if this condition is met, then I want to do something. Oh my gosh, do is a keyword as well. I want to something, okay? And then I might have an else, but it doesn't matter. So what condition would you like to use? Who can think of a condition? We've got two numbers to play with. We don't have to play with them. We've got some constants as well, so we can do a whole bunch of playing around if we want to. Someone's asked a great question. Would you be able to use if statements when using scanf? Yes, you can. Not quite in the way that you've said, but you can use input from scanf absolutely to answer an if else question. Okay, so a good one is to check number one, is number one less than number two? Okay, and so the same way as in maths, we've got all the same symbols. Okay, we can use your greater than, we can use the less than, we can use, and this is where the equal will come in, we can use equal to. And so notice that now to say equal to, I'm actually using two equal marks. Okay, so in C, if I use one equal mark, it means I'm assigning a value. If I use two equal marks, I'm checking equivalence. I can't spell. Okay, so you're going to be using two equal signs if you're going to check whether something is equal to something else. And you're going to use one equal sign if you're going to assign something to a variable. Okay, so less than, okay, then we have an equal to, then we have less than and equal to. What else can we have? Not equal to is an exclamation mark with a single equal sign. That means not equal to. Okay, so you've got less than, greater than, equal to. You've got less than or equal to, greater than or equal to, and you've got not equal to. Okay, so you've got a whole bunch of things that you can do. Okay, so let's check if one number is bigger than another one. So if number 1 is greater than number 2, then I want to do something. And I think the easiest something for us to do is to print out that number 1 is greater than number 2. And I'm going to say %d is greater than %d. Okay, and my variables are going to be number 1 and number 2. Okay, so let's see what happens when we run this piece of code. So I'm going to DCC it, and I'm going to run it, and it runs, and it doesn't print anything out because I forgot to have a printf statement. Oh, well, no, I haven't. I do have a printf statement, but what happens? What am I checking for, actually? Let's see if you can see the mistake that's happening here. Can anyone see the mistake? What did I check for? Blindly? Yeah, well done. So the condition is false. The condition is not true. So over here it's saying, is number 1 greater than number 2? Well, this is false. It's not true because 5 is not greater than 11. So what it does is it's checked this condition in here. It said, okay, this condition is false, which means I don't have to do anything inside this block of code. I'm just going to go straight out here. Okay, so what we can do is we can have another printf statement here to catch it out, and we can say that it's less than, although that's not really fair because then we might have an equal as well. So maybe I won't do anything yet. We can do it with else's. Okay, but if I have it the other way, just to be, I'm going to make this 50 just so that it's going to work this time, just so that you can see it going into that. So now I'll compile it and I'll run it again, and this time it's going to say 50 is greater than 11. Okay, so because this time it's checking, is 50 greater than 11? That's actually true, isn't it? 50 is greater than 11. So if something is true, then I'm going to go inside this if statement and do whatever is happening inside here. So whatever it's asking me to do. And it not necessarily doesn't have to be a printf statement. It might be do something else, but it's going to be something to do something. Okay. How's that? Is that's still okay? Yeah. Because you do conditionals in other subjects as well. So I think you would be familiar with them. What about if we check for equivalence, okay? Or let's use a constant in there so you can see that I can use constant as well, okay? I'm going to use the meaning of life constant, okay? So that means what I'm doing for now is I'm checking, is 42 greater than 11? And note here, this is a good time to print it out as well then, okay? So then note here, I'm going to say I want to put in a meaning of life, and then here I'm going to have the number 2. So let's see, is this true, 42 greater than 11? Yes, it is true, which means that this statement here is true, this condition is true, which means I'm going to do whatever is inside this block of code. So whatever is inside these curly brackets. So I'm going to print out this statement. Let's try and compile it. Okay, it's just telling me a warning that I haven't used number 1. So I'm going to run the program because it's a warning, but you should probably, when you do your programming, change it to not have warnings as well. Okay, and it's telling me, yep, 42 is greater than 11. So this has told you a few things. First of all, it has shown you that you can print out a constant, okay? So I've used a constant in a condition to compare it, and I've also used a constant to print out as well, okay? So also note a few things for style. I started out my if statement, I opened up my bracket, and then I indented it here. I just use a tab to indent it, okay? So every time I enter a curly bracket, I'll indent it once. Every time I make another block, I'll indent it. It makes it much easier to read, unless you have a nest of if statements, in which case it does not make it easy to read. And you'll see we have a lab exercise that will make you have, you know, a nest of ifs so that you can see what that feels like. So again, remembering that someone else has to read your code. Okay, what about if we have a not equal to, okay? So I can check if it's not equal to by using the exclamation mark and an equal sign. And I can say if it's true, then I can say that is not equal to the other number. Okay, and then I'll run it again. And it's saying 42 is not equal to 11. Okay, that sounds pretty good. So fantastic. Okay, that's kind of what I wanted. So what happens if I want to check for another condition? So what happens if I'm saying here, okay, is it greater than? But here I want to also check, or is it less than as well? So this is where I can have an else. So I can check for a few things. So I can say if in here, and then the code will check my condition here. And if this condition is false, then it will skip down to an else to check the else condition. And again, in here, I'll have my next condition. So perhaps here, I'll check the opposite way. So is it less than number 2? Okay. And then I'll open another curly bracket and I'll indent it again. Okay. And what's it going to do? What can we print out here? Well, it's going to go the opposite way, isn't it? Okay, so I'll say it's less than. Okay, and okay. Why not 2 if statements? Good question. It's quite bad style if you can, because usually when you start an if statements, you're testing one series of conditions. So if you start going on to the next if statements, it's like you're testing the next set of conditions. So sometimes you'll have an if and then you'll have another if in here, because it's like you're separating out two different sets of conditions that you're testing for. So usually if we're in the same branch or in the same like movement of branches where we want to go different ways, that's why we want to use this else. So let's try this way, okay? And let's make, I'll make number 2, unhelpfully 45. Okay, so let's see what it prints out now. I really have to stop using, where have I lost a semicolon? I forgot an if, that's what I've done. There we go. Okay, so I forgot an if there. So it's if, else if, and then no wonder that was making no sense. Okay, so if, else if something else is happening, else if something else is happening, I could have another condition here, and I could have another one as well, else if, else if, else if. So I could keep going for a long time. It's not advised. Style is very bad if you keep going for a very long time with a lot of, but sometimes you do have a few conditions to check. Okay, I think that we might have to what if it's equal? That's a very good question. So it's another condition that you can check for. I didn't troll you. It's Friday afternoon, maybe a little bit. Okay, meaning of life. I could check equivalence here as well. So what if it's equal? Then I can print out that they're equal. Number 2. Okay. So then I could check that as well. So we don't use switches in this course. So please try and avoid them. There is a reason for it. If you would like to know what that reason is, you can ask on the forum, but it's a good reason for it. And if they were equal, so if let's force it to go into that statement. Let's force it in. And let's run it. And it's going to go in here, because here it's going to be false because it's not greater than. Here it's also going to be false, so it's going to skip to the next else if. And when it gets to this third place, it's going to say, okay, this condition is true, which means this is where I need to go. Now, if this condition was false as well, it would just switch out of here, and then it will go all the way down to the bottom, down to your return 0, and that would be that. Okay, we're going to start to round up after this. So please, any questions in the chat, we will continue on as well next week. I also like to get some feedback from the lectures. So I'm going to ask you for some feedback. Perhaps you wanted the pace to be slower, the pace to be faster, or any other feedback at all. Please keep your feedback constructive so I can actually do something about it. Please don't comment on what I'm wearing. Unless you're saying it's fabulous. That's about it. So please follow this link and leave me some feedback, and then I'll let you know in my notice and announcement to everyone what I've done to make changes for next week. Thank you all for tuning in on a Friday afternoon. I know it's not it's not an easy time to be. Some of you came in from a 2-hour maths lecture, so my goodness, commitment. So thank you for that. I hope you go and enjoy your weekend now, and I'll see you all next week for an exciting adventure.